So first you have to select your file. Again you have to select the same file. So from this curve I can get the idea about there is a little bit ionic character in my sample. So this is a cationic surfactant pure. Now I have to fit the data. So fit. So initially I am assuming that my all micelles are same size, so select monodisperse. Then this is a ellipsoidal shape, so I have to select ellipsoidal core shell model. So randomly I am putting the value around this 50, 20, and this is a scattering force at scattering contrast. So if you know how to calculate it, you can calculate and put this value as a constant. Otherwise you can fit it. Now if I'm you have to put your cursor here, so right hand side at the bottom you are seeing the value 0.037. so this is your background value, so you have to substitute value background. Then click apply, fit. Okay. Then again previous, try to fit the core value. So if you're getting error, don't panic. uh, Start with the structure factor first. For ionic surfactant you have to use Hater Penfold model. So this is the value, like you have to select RHS and 0 point. This is the concentrations of your material. So if you have 5%, then you have to select 0.5. Temperature is like 30 degree. So you have to convert it into Kelvin. 71.2. If you are adding some kind of salts or XYZ, so you have to put the value here. And this is a charge, a fractional charge, so I am taking initially 25 value, then click fit. So if you will get error, just remove this, try to fit with this too, then do fitting with this single one. Okay, so I will fit this parameter a little bit later. Then now I will try to fit RHS again. Okay, if I'm getting error, okay, I will do it later. So from monodisperse now, for log norm means a polydisperse. Monodisperse means what? Initially I have assumed that my all missile size are same, but it is not true. So this is a polydispersity, so you have to put the value between 0 to 0.5. So initially I am assuming I'm like 0.25. If we are using ellipsoidal core model, then you have to use this uh, row value is 3. If it is a spherical, then 2, and if you are a road like structure, then you have to put 2. Okay, and this value is you have to take from here A. Okay, or the portions which is your hided here, that particular you have to choose. Okay, so again I am fitting these two things. So don't fit mo more than 2 or 3 parameter initially. Instead of this, initially you have to fit uh, like 1 or 2 parameter together, then start gradually fit a multiple parameter. So this is only compensations. I am not getting proper value, so I am decreasing this value. But then try to see that this red fitting line will go near to my data. So do it trial and error this type and try to reduce this value of the reduced chi-square near to 1 or maybe below to 1, and once you will get this value, so this fitted line will completely overlap to your data, and this means that your fitting is completed and you can extract the data. Okay. Click on file, export, IQ, then browse where you want to save your data. Okay, so within the same file I want to save, so and with the same name, so I am selecting the name, and then I have to write dot txt, because later on I will throw this data in origin or some another software. Okay, click on save, so and export, and you can save also, like save project. So within a same file I would like to save, select, then same name, but this time I am not selecting extension, just only name, and save. Okay, so thank you.